Hello everyone. Looking at the map right now, we've got quite a bit of activity happening across North America, and there are some interesting patterns developing that I want to walk you through. What's particularly striking about today's setup is how clearly defined the regional differences are becoming across the continent. Starting with the big picture here, what immediately stands out is that the eastern half of the United States is showing much more active weather compared to what we're seeing further west. There's a clear moisture flow coming off the Atlantic that's influencing conditions along the eastern seaboard, and this is creating some pretty distinct regional differences in what people are experiencing today. The contrast between east and west is really quite remarkable when you look at the broader scale of what's happening. This type of continental scale organization tells us something important about the atmospheric setup. When we see these kinds of well-defined patterns, it usually means the larger weather systems are becoming more organized and stable in their positions. That often translates to more predictable regional conditions, at least for the next several days. Let me direct your attention to the Atlantic coast first, because this is where a lot of the action is happening. From Florida all the way up through Georgia, the Carolinas, and into Virginia, we can see the influence of that oceanic moisture really clearly on the map. The rain areas are scattered, but persistent in many spots. Some zones are dealing with lighter precipitation, while others are seeing more steady activity. What's particularly interesting about this coastal pattern is how the moisture is organizing itself. Rather than just random scattered showers, we're seeing these more coherent bands of precipitation that suggest the atmospheric setup has some real structure to it. This kind of organization often means the weather pattern has more staying power than just isolated, short-lived events. Florida is particularly interesting right now. The peninsula is showing that typical variable pattern we often see down there. Humidity is running high along the coast, and we're seeing these brief rain passages moving through. For folks in Florida, I'd say keep that umbrella within reach, but don't expect it to rain all day either. That's just how Florida tends to work with these patterns. The Florida Peninsula's unique geography really shows up on days like this. The interaction between the Gulf and Atlantic moisture sources creates these localized effects that can make conditions quite variable from the east coast to the west coast of the state. What you're experiencing in Miami might be completely different from what's happening in Tampa, even though they're relatively close together. Moving up the coast, the Carolinas are seeing some of the more organized activity. The moisture coming off the ocean is interacting with the land in ways that are creating these bands of precipitation. It's not severe weather, but it's definitely noticeable, and it's the kind of setup that can lead to some local variations in intensity. The topography of the region is playing a role here too, with the coastal plains responding differently to the moisture flow than the areas further inland. The interaction between the ocean moisture and the land features is creating some interesting patterns across the Carolinas. Areas closer to the coast are seeing more consistent activity, while inland regions are experiencing more intermittent conditions. This gradient effect is typical when you have strong moisture sources from the ocean encountering varied terrain. Now, shifting our focus to the northeast, we're seeing a somewhat different character to the weather. Areas around New York, Pennsylvania, and New Jersey are feeling the influence of cooler air masses, and this is mixing with the available moisture to create mostly light to moderate precipitation. The New York area specifically is looking cooler today, and with the wind factor, it's probably feeling even chillier than the actual temperature reading. If you're heading out in that region, layering up isn't a bad idea. The northeast pattern shows some interesting complexity when you examine it closely. The urban heat islands of major cities like New York and Philadelphia are creating slight modifications to the overall pattern, leading to some localized differences in how the precipitation is developing. These metropolitan effects might seem small, but they can actually create noticeable variations in conditions across relatively short distances. Further north into New England, the pattern takes on yet another character. The combination of terrain effects and the influence of the Atlantic is creating conditions that vary significantly from the valleys up into the higher elevations. Mountain areas are likely seeing different conditions than the coastal plains, which is pretty typical for this region when these kinds of moisture flows are in place. The Great Lakes region is showing its own unique signature on the map. Across Michigan, Ohio, Indiana, and the surrounding areas, we've got widespread cloudiness that's creating those gray, overcast conditions. The precipitation is mostly on the light side, but the influence of the Great Lakes themselves is keeping moisture levels elevated and contributing to these frequently changing conditions. That's pretty typical for this region when we get these kinds of patterns. What's interesting about the Great Lakes area is how the water bodies are modifying the air masses as they move through. This creates these localized effects that can make conditions quite variable from one spot to another, even within relatively short distances. It's one of those regions where you might see sun breaking through in one area while it stays grey and drizzly just a few miles away. The lake effect influence is particularly noticeable today, even though we're not seeing the kind of dramatic lake effect events that make headlines. Instead, we're seeing the more subtle but persistent influence of these large water bodies on the regional weather pattern. This influence helps explain why the cloudiness is so widespread and why conditions can change relatively quickly across the region. Each of the Great Lakes has its own personality when it comes to weather modification. Lake Superior, being the largest and deepest, tends to have the most significant effects, while the smaller lakes create more localized influences. Today's pattern shows how all of these effects combine to create the complex weather picture we're seeing across the region. Moving into the central United States, we're seeing a pretty different story. From Illinois stretching out through Iowa, Missouri, Kansas, and Nebraska, the pattern becomes much more stable. The map shows the influence of higher pressure in this region, which is keeping things relatively calm. There are some transition zones where we might see light rain areas, but the overall picture is much more settled than what we're observing further east. This central stability is creating an interesting contrast with the more active eastern regions. It's a good example of how these large-scale weather patterns can create very different experiences for people depending on where they happen to be located. The high-pressure influence across the central regions is acting like a buffer, keeping the more active eastern pattern from spreading further west. The Great Plains are showing particularly stable conditions today. The wide-open geography of this region means that weather patterns tend to be more uniform across larger areas, and today that uniformity is working in favor of calmer conditions. This is the kind of pattern that farmers and outdoor workers in the region appreciate, as it provides predictable conditions for planning activities. The southern United States is showing yet another variation on the theme. Looking at Texas and the surrounding areas, we can see some remnants of humid air, but there aren't any signals of large-scale storm development. The moisture coming up from the Gulf of Mexico is contributing to increased cloudiness from time to time, but it's more of a nuisance than a major weather event. The pattern suggests conditions that are unsettled, but not particularly problematic. The Gulf Coast influence is subtle but persistent today. Rather than creating dramatic weather events, the Gulf moisture is providing just enough instability to keep things interesting without becoming problematic. This is actually a fairly common pattern for this region during certain times of the year. When we look toward the western United States, the contrast becomes even more pronounced. California, Nevada, and Arizona are showing mostly stable conditions with very limited precipitation activity on the map. The coastal areas of California might see some marine layer cloudiness, especially during the morning hours, but the interior regions are looking quite clear. This stability extends inland and creates a stark difference from the more active eastern portions of the country. The western stability is quite impressive when you consider the scale of what we're looking at. From the Pacific coast all the way to the Rocky Mountains, conditions are remarkably consistent. This kind of large-scale stability often indicates that the jet stream pattern is well organized and likely to maintain its current configuration for several days. Turning our attention north to Canada, the southern portions are showing conditions that mirror what we're seeing in the northern United States. Ontario and Quebec are experiencing that cooler, cloudier weather, with areas of light precipitation scattered throughout the region. The further north we look, the more stable and calm the pattern becomes, which is fairly typical for this time of year in those regions. The Canadian pattern provides important context for understanding what's happening in the northern United States. The continuity of conditions across the border suggests that the atmospheric pattern is truly continental in scale, rather than being driven by more localized effects. The ocean patterns are also worth noting because they're driving a lot of what we're seeing on land. The Atlantic is clearly showing those moisture flows that are impacting the eastern seaboard, while the Pacific side appears much more stable without any major systems approaching the west coast. This oceanic contrast is one of the key drivers behind the continental weather divide we're observing today. What makes this overall pattern particularly interesting is the clear regional distinctions we can observe. The eastern regions are dealing with the influence of oceanic moisture and cooler air masses, creating these areas of precipitation and increased cloud cover. Meanwhile, the central regions are under the influence of more stable high pressure, and the western areas are experiencing generally calm conditions. These kinds of continental scale contrasts don't happen every day, and when they do develop, they tend to persist for several days. That means the general characteristics we're seeing now are likely to continue influencing regional weather patterns for the immediate future. Understanding this persistence helps us plan better for what's coming in the days ahead. The key takeaway from looking at this map is that location really matters today. What you're experiencing in one region might be completely different from what's happening just a few states away. The eastern areas need to be prepared for continued unsettled conditions, while central and western regions can expect more stability. This pattern will continue to evolve over the coming days, but the fundamental drivers we're seeing should keep these regional differences in place. The moisture source from the Atlantic will likely continue to influence eastern areas, while the more stable pattern across central and western regions should maintain its character. We'll keep monitoring how this develops, especially along those transition zones where different air masses are interacting.